volumes with cross sections. As we've been integrating, we have started with Riemann sums. So we found the area under the curve. The area under the curve represented the value of the integral. Next, we moved forward and we moved on. And we moved to area between two curves. So when we did area between two curves, we found the top curve minus the bottom curve, and once again, found the area between two flat surfaces to kind of make it three-dimensional. Now, to find volume, we're going to integrate area. So just like the derivative of volume gave you this area, or area, we're going to integrate area to get volume.
Attention any boys baseball player or girls softball player that needs to eat lunch before leaving for their trip may do so, period 4. Please get your lunch. The boys are to eat in the community room. The girls are to eat in the library. Again, any girls or boys softball, baseball players may eat lunch, period 4. The boys get your lunch and report to the community room. The girls to the library.
Great. Our focus will now shift from using definite integrals to finding the area of two-dimensional shapes to finding the volumes of three-dimensional shapes. So we have to think three-dimensional. So this is called volumes with cross-sections. So a cross-section is the shape it makes. If I wanted to find the volume of my coffee cup.
Circle.
Exactly. The cross sections would be circles. Because if I cut this into a million pieces, I would find the volume of the circles. Take it back however far it is. So you would find the area of the circle and then integrate the area of the circle from like the base height to the top. That makes sense?
Yeah.
Okay. That's what we're going to be doing, but with functions. So the Confidence Center in Kansas City, Missouri is one where you can really see like the cross sections, like we kind of made it. It also reminds me of like the amphitheater in Sydney. So again, that's one where you can see it. So for cross sections of area where A of X is taken perpendicular to the x-axis, that's where it's easy because x-axis is like this way. When we start taking them perpendicular to y's, it's really nice. So the AP Calc exam will focus upon 4 familiar shapes from geometry: the square, the rectangle, the semicircle, and then triangle. So we're going to complete the table below, providing the information, the attributes of the figures, and the areas. So
that was an ambiguous shape. The top, the volume of the top, it wasn't a circle, it was a square root function. That is very true. No chance. But that's not a semicircle.
yeah, the circle formula is x squared plus y squared equals 4 squared.
It was 4 minus x under the square root of that.
It was c of x plus square root of
Oh, yeah.
You had to find c.
I got it right. Someone got set.
Yes, I did.
Alright, fill in your table with all your formulas. You should know these.
Did you just say you don't know them?
You should know
I struggle with these.
Oh no.
well,
Alright, in order to find the area of a square, what do we need to know?
one side.
One side.
Oh, that's a, why did I write rectangle? Just circle.
That's tough.
reason. Because it's a square formula. I'm trying to get there for you. I don't know.
So area equals S squared. A rectangle we need like so area equals one split. A semicircle, what do we need?
Radius of
Good. Radius. So area equals 1/2 pi r squared, and then a triangle.
base, height, form, angles,
Yeah, because at one point I had to do like I was doing this with a bookend, and he got an equilateral triangle. So you only have the base. So you had to use properties of 30, 60, 90s. So it was equilateral, so then it was 63.
45, 45, 45.
Equilateral. So all are 60. 60, 60. So then you cut it in half to find the height, which made it a 30, 60, 90.
That's how I remember. Equilateral and equal angle.
1/2 base times height. Good? Right? Grant?
Bring it back down there.
Example 1. We have a triangular base. So you want to find the volume of the solid in which the base is the region bounded by the graphs of f of x equals and g of x equals and x equals. So the best way to get this is to sketch the curves.
Start with x equals 0.
I knew it. Oh, I knew it.
Okay? X, f of x equals 1 minus 1/2 x.
Starts at 1.
And goes down.
Over 2. Right? Alright, got that.
And then g of x starts at negative 1. Goes up.
Never mind.
There's only one triangle, the answer is 0.
So then it says the cross sections are perpendicular to the x-axis. So if it's perpendicular to the x-axis, here's your x-axis. So they're coming up off the graph.
What the hell?
We're making a three-dimensional shape. So this is like a triangular base with squares coming up.
How can it be square? We're finding a triangle.
Cross sections are squares.
The cross section of that cup was not a square.
The cross section of this cup is a circle.
No.
Okay, but
So
like,
that would be like asking for triangles
If
on
the
it.
base is a triangle, wouldn't the every
Well,
other cross
think about
section
it,
be a
Corey,
triangle?
Corey, think about a rectangular
a
pyramid.
triangular pyramid, yeah.
Alright, so I have a triangle. How are we putting squares on top of it?
Look at the base of a pyramid, Corey.
Yeah, but the base of pyramid is paper squares on top.
Just, you're filling in the triangle. You're not necessarily doing triangle. It's not, it can be a triangular
The bottom
shape.
of the
You're
shape
doing
is a
square.
triangle, but there's squares on top of it.
Matt can make whatever shape it wants, Corey.
So then, what would the length of one side of that square be? How would we find out what? the same, right?
Yeah.
So if you look at one square I drew, what's one length of a side?
One.
X. 2.
You look at the one to the left and you.
Yeah, I'm trying to look at these squares. I'm not sure where I'm looking at. Alright, let's start again. This isn't happening. One more.
Here's our graph.
Can you explain to me the triangle?
The triangle is the base.
Oh, okay. What's
On top of the triangle,
It's H.
you are laying
H.
pieces of paper that make their rectangles.
H.
Well, in this case, we're squares, meaning the length, the height, are all the same.
H. The variable
No,
H.
G is the base.
It is
That's
the base. It is the base of the triangle.
Look at the drawing.
I just don't get why you're drawing outside of the triangle.
Because it's three-dimensional.
It's
Coming up.
square. The base of the height is the same.
If I were to put a piece of paper on top of this
You're
calculator
right.
and make this three-dimensional, and if I were to take a piece of paper and cut it into the triangle, assuming it was all the same height on top, these would all be squares. But the base of the calculator isn't necessarily a square.
Look at a piece of pizza. There's a triangle or square and pepperoni on top of it.
So the square itself is going from the top curve to the bottom curve to get you S.
Yeah.
The length of the side is going to be the top curve to the bottom curve every single time. The length of the side is going to be represented by this distance. It's going to change. So S is equal to red minus purple.
And I don't have it color coordinated on my paper.
It's the top piece, so the bottom piece is going to represent the length of the side. So it's 1 minus a half x plus 1 minus a half x. So that gives you a negative half and a negative half, which gives you a negative whole. 1 plus 1 is a.
Damn straight. Well, I was almost there.
Minus. Yeah, I said you just need a variable.
I don't know what you said. Hold on. Why wouldn't it just? Why?
So what's the area of a square? Side squared. So this is the side. So in order to find the volume three-dimensionally, we're going to take the area times the x. So in this case, our area is 2 minus x squared dx, because dx represents our width of the squares. This represents our width of the squares. So what to what am I integrating on?
Negative 1 and 1.
Because you need three-dimensional. Area times width will be volume.
0 to 2.
0 to 2. Because what variable are we integrating with respect to? So you start with x to 0 to where they intersect.
Hey, whoa, we don't even break that up. That's a low blow.
Now you have two choices. U sub or FOIL. Give me a final answer. U sub or FOIL.
Did you say negative 8/3?
Take that. I said straight up. Well, because when boiling it would be 2 to the third over 3 would be 8/3 minus 8 plus 8.
That is my favorite. All right, now same graph. That's the volume of that shape
With the base of the triangle.
with
or
a
square.
triangular base and square cross section. Stop making me say the wrong
Could you
shape.
put a square cross section of a triangular base?
Well, guess what? You're gonna love this. You're putting a circle on a triangular base.
Why?
So like,
That's literally just a pizza.
so just imagine it's like a triangular base. I'm gonna make it come out at you this time. And now we're putting circles across it.
Again, I feel like
It's just a backwards pizza.
So it's like half of a birthday hat.
No, you just gotta think of it like a pizza. cut.
Half of a birthday
I
hat.
thought that this is a triangle. Say my thumb is a triangular base, right? And then this would be a semicircle. And this would be a semicircle. And then this would be a semicircle.
No,
And
you're
that's how we're getting
backwards. You're going backwards. You're going up. That would be with perpendicular to the y-axis. We're going across. You have to imagine my coffee cup sideways.
Then how are we getting that height?
So you're cutting a million triangles.
How are we getting it's
The
three
height.
dimensional, right?
Right, but it's a square. The square height is the same as the base. Height of a square is the same as the base. A circle radius is the same everywhere.
That's why it's
So
equal
the
to
radius is with respect to the base. R here is the same as the R height.
Right, so what I'm saying is, say we have our shape, and we lay things across it this way, don't we already know the dimensions of this?
We're going back,
It's like
not
a
up.
filing cabinet. You're filing it in.
But you see what I mean?
Yeah, Corey,
We're laying
it's like
things on top
You have
of
a
it.
square file
and we
cabinet,
already
you're
know
putting
the
triangles to the
dimensions
back
of
of it.
this.
Yeah, we're not laying it. It's not stacking. It's like filing it in.
Yeah, you're filing.
Yeah, Corey, you got a triangular filing cabinet and you're putting semi-circles into the back of it. Does that
No,
make sense?
it's just-
What I'm saying is we have the area
I'll
of this
cut you.
already. Why would we need to find
We're finding
that?
the three-dimensional area. You have the flat area. We need the 3D. You're finding volume, not area.
So what
We
I'm
are
saying
finding
is,
this, okay, this right here is the volume of a semicircle. So a semicircle is 1/2 pi r squared. We're integrating once again from 0 to 2 because it is from x equals 0 to the point where the two lines intersect. The radius is going to be
X minus 2. 2 minus X.
2 minus x divided by
2.
2, because radius is half the length. So in this case, the diameter of the circle is 2 minus x, because we already determined that is the length of this base. So the radius is half of that.
So it'd be 1 minus X over 2, which is our function. F of X.
I guess my
So-
problem.
Do I get a bonus point for that or something?
The volume then is the integral of the area. So if the area is 1/2 pi r squared, the volume is its integral. So you pull out the 1/2 pi, because those are constants, and you integrate the volume, which is 1 minus 1/2 x squared dx. Personally,
Nope.
I'm not transforming it. I'm leaving this
What would you choose?
as 2 minus x over 2 squared because
You sub.
we already know, no, watch. this becomes the same as 2 minus x squared over 4. That's properties of exponents. So what is a base of 4? It is a
perfect square.
no, it's a constant that you can pull out.
It is a perfect square.
But it is a perfect square.
This is stupid. I just
So I'm going to bring out high eighths now from 0 to 2. And now look what I'm integrating from again to again. What's the integral from 0 to 2? 2 minus x squared.
8/3.
We already know it.
Pi
So you
eighths.
plug it in. So the volume with
And then the 8's
semicircle
cancel out, it's pi over 3.
is pi over 8 times 8/3,
I just did this in my head.
which is times 4.
This is right. This is right. Hold on.
Oh dear me, Corey.
Hey, Jess, stop it, please.
Can I?
So, this is the two-dimensional area, correct?
That's a rectangle.
Yes. So therefore, it's a two-dimensional area. What changes that? So say we're on a graph here. What changes that?
Now, the cross sections are perpendicular to the x-axis are rectangles whose heights are unchanging. The heights are 3. So, what?
That's what I was going to ask. So, does this
On 6 minus 3.
Oh, we don't have rectangles.
What is the area of a rectangle?
We don't have rectangles.
So the area of a rectangle is length times width, or height times base, right, whatever. So what did we determine was the base length? Okay. So it's 2 minus x. Now, the height exactly is, so you distributed yours. I wouldn't distribute my 3, it's a constant. I'm bringing it out. When you said 6, I didn't have 6 in my head at all. Exactly. So I bring my 3 out, 0 to 2, my function times the x. Because the height's unchanging, it's a constant. So now I can bring that out in front.
Where can we find this out? It's a problem. So how will we know? Is my paper different than everyone else's? No. How will we know if bounds change?
Yes,
That's
it
what
is.
my question was.
Oh my, I've been writing on the wrong page.
This whole time. That's not our fault. That's your fault.
My paper is in the trash.
No wonder. I was like, what? This does not say rectangles at all. Trying to solve this puzzle with all of the pieces.
So will the bounds ever change on us?
Not if you're talking about the same original function.
No, it's never. I should have been into it. I know you use those two equations.
Because I did top minus bottom. So that's why I like you do area between two curves first. Because,
How does the top minus bottom solve for the distance?
you know, think about, okay, well, my problem is now that I've erased my graph. But if you have cheese and crackers, so you have your two graphs that meet at this point. So at any given time, if I want to find the length from point A to point B,
You start at
the
2.
distance between them, if you go back to distance formula, it's like x2 and y2. And what you do is you subtract y2 minus y1 plus x2 minus x1. So what happens here is instead of getting that individual point, we've created the structure of the line. So the line is the height
Oh,
of
we
the
didn't
twin.
integrate them. We just wanted the distance. How did I do that?
No, all you did was take the top curve minus the bottom curve to find the height of the curve.
This is for my professional geometry.
Alright. Can we get through like one example, maybe if we do a second one, it'll help?
Yeah.
I feel like we're getting caught up on this one.
Sorry.
I feel like if we just did a second one.
Jackie, very English there.
Okay, the cross sections are equilateral triangles. See, here's our 30, 60, 90 that I had to do this weekend. So now you have triangles on triangles, Corey.
But they're different. They're
So
different triangles.
here's the base.
This is different triangles.
Now you're building a three-dimensional triangle on top of that. So the height of the three-dimensional triangle is unknown. So this triangle on top,
So the base is 2 minus x.
exactly, the base of the triangle remains the 2 minus x. If this is a 30, 60, 90 this way, that means all the sides are 2 minus x. This is equilateral. So that means the hypotenuse is 2 minus x. If you don't have your 30, 60, 90 triangle memorized, like I do, you would have to do Pythagorean here.
Isn't it 1 square root 2 and square root 3?
You're almost there.
I was suspended for this lesson and she made me take the test the day I came back.
So the hypotenuse is like your 1.
So I had to learn it in 30 minutes before the test.
Think about what's the sine of a 60-degree angle.
Root 3.
Two. 3 over 2.
Yeah.
So if the 30-degree is 1/2,
Now I have the 3 and the 2 backwards.
and then so here's your 30, yep, here's your 60. This is your root 3 for the height.
For the
height.
vertical. Oh, man.
So it's the base, so it's 2 minus x, and this is over 2. You gotta cut the base in half. So then here, this is going to be root 3 times the 2 minus x. So the height is equal to root 3 2 minus x, and the base is still 2 minus x, because it's the whole triangle. We only needed half to look at the 30, 60, 90.
So is it over 2 and not 4?
The half was for the 30, 60, 90.
Because it's the height times the base.
Yeah. Well, but the base in our triangle is only half the base, because it's the triangle in half. Yeah.
Wait, so why do we multiply by the base?
The area of triangle is 1/2 base times height.
The height is root 3 times, is the base times the height.
Right. So the base is 1/2 2 minus x, because it's only half the triangle. The whole base is 2 minus x. What?
But why is
Height
that?
is just equal to 3.
Times. Okay, here's a 30,
Why
60,
are
90.
you
Here's a 30, 60, 90. It's a 2a root 3. Ready? So it's a root 3. This is 1/2 a, and this is a.
So then why is it different? If it's multiplying by A.
A is 2 minus x.
No, A is not. Yeah, A is 2 minus
So
X.
maybe I have this wrong. This is 2.
2.
Sorry, this is 2a. The half is for the 445, 45.
Because our base is only half the original base.
Is the a value. So if 2 minus x equals 2a, you need to solve for a. 2 minus x equals 2a, because this is 2 minus x. therefore A equals 2 minus X divided by 2. And then you have to multiply this by Yeah.
When we did conjunction, we just did. You can circle triangles.
Well, I ended up with the square root of 5x squared minus 16x plus 12 over 2.
So should we?
Our last test of this year is all on this and area between curves. So bring out the 1/2 base times height. Bring out the root 3. Bring out the 2.
Wait, can you
So I brought this out.
So the actual.
And I brought out the half for height, like in the formula of the triangle. So half for the formula of the triangle. I brought out the constant. And then base times height is going to give me 2 minus X squared again.
So, but if we were to write this as a regular angle, the integral from 0 to 2 of 1/2
Yep.
times
Yep.
root 3 2 minus X over 2
Yep.
times 2 minus X.
Yes. I just can't write on my board here.
How can we pull out those constants when they're not in all of them?
Multiplication is commutative, so all constants can come out. Because it's all just one singular number. Technically, this can become root 3 over 2. It's going to be the square root of 3 over 4 times 8. The integral from 0 to 2 of 2 minus X squared dx. Yes. That becomes 2.
Oh, have you missed a doozy of a lesson?
You got a lot.
You missed the worst lesson.
Worst lesson, right?
You're
Think of
not.
it as a filing cabinet. That's all I gotta say.
I was trying.
Honestly, it's
Let's
probably
see if
good
we
you
can
wouldn't
get
do it
one
with his
example in for Deja. Alright.
I don't have to know. My neck is stuck here. That I told you I tweaked my neck yesterday. I have a file in my bag. My neck hurts so bad. I don't know. Maybe cast it.
Ready?
It hurts so bad.
We're gonna do this one for you real quick.
And then we're going to take a walk.
Wait, so that's 8 squared 3 over 12?
No, that's move quickly.
No, it's root 3 over 2. 2 squared is 3 over 2. 3. 40. 34. 2 squared is 3 over 3. Yeah.
I just was trying to say.
Alright.
Yeah, 8 12. It's just 400 a minute. The 2 mile takes 10.
Draw your circle
Takes-
real quick. Draw your
Oh, yeah.
circle real quick. Find the volume of a solid in which the base is a circle. Maybe this one will be easier for you because it's like my cylinder. Alright, so the base is a circle at the origin with a radius 2. So if base is a circle at the origin with radius 2, area of the circle is x squared plus y squared equals r squared. So this is x squared plus y squared equals whole. X squared plus y squared equals r squared radius 2.
So why squared 4 minus X squared?
Y equals plus or minus the square root.
I heard him say.
Alright. So, if you were going to find the distance from the top curve minus the bottom curve, aka the diameter, so it
That
would
would
be
be
2.
2 times the square root of 4 minus X squared.
Yeah. 2 square root. This line here. 2 square roots of 4 minus x would represent the diameter of the circle. So if on top of that circle, I put squares. I know, you hate this. So if on top of a circle, I put a bunch of squares, the base of the squares are going to be the diameter of the circle. A square has the same length across its base as it does for its height. So the length of the base of the square would be represented by, but a square is squared, so we have to make it square. Okay. So area is 2. You could use some part of it, not necessarily all. Right. So it's the square's area integrating from where to what? What? So you did 0 to 2 of the 2 out in front? That works. Or negative 2 to 2.
Can't you FOIL this and make it 4 times 4 minus?
We're going to get there too. That's something for my next. So you can either do negative 2 to 2, or use your symmetry and double it and go 0 to 2. And as Alex said, that 4 is going to distribute in. So 2 squared is, the 2 is going to distribute in. The square is going to distribute in. So you can bring the 4 out. And if we go from 0 to 2, it's 8. What's something as a square root square?
It's something 4.
So you integrate 8, 0 to 2, 4 minus x squared. 2 squared is 4, and you put a 2 up there. 4 times 2 is 8. So you get 8, 4x minus 1/3 x. 2 to 0. 8. 4 times 2 is 8. 2 cubed is 8. 8 minus 8 thirds. It's going to 3. Yeah, you're better off changing this to 24 thirds. So 24 minus 8 is 16. 16 times 8. 16 times 8 divided.
I could have done it. I could have distributed the 1
I think you overthought. So now the cross sections are perpendicular to the x-axis and are semicircles. So on top of my circular base, I now have semicircle sides.
So the radius of the semicircle is the diameter of the circle.
So think about what you're looking at. Here's the width of that circle, and we have semicircles on top. So the radius is going to be the same as the radius of the circular base.
Which is for
So volume, 1/2 pi.
How do I know which one to do it?
because that inside area is going to be negative 2 to 2, again, is the 0 to 2 times 2.
That's why I shouldn't distribute it in before I.
So you get your 16 thirds times pi. Yep.
Will the following students please report to the office? Zach Candlecart, Marcus Burrows, Landon Strimmel, Cameron Bohonic, and Xander Anderson. Those students please report to the office.
The integral from negative 2 to 2 or 0 to 2 is 16 thirds.
Right. Wouldn't it would only be from 0.
128 thirds is the square. The inside area.
Right, but we did pull out a 2 in the first one.
But we could also pull out a 2 in this one.
I pulled out a 2.
16 thirds isn't an integral from negative 2.
Yes, it is.
So it's an integral from
0
0
to 2
Times 2.
The times 2 didn't come until later.
Oh.
The times 2 is where we got our 128 thirds.
No.
Yeah.
No.
Because I
That 128 came from the 4
And
that
the
you
2
squared.
is 4 times 2.
Yeah, 4 times 2 is 8.
Here, I can go back.
Oh, yeah. Just saying. What we just did.
Oh.
Remember, it's the symmetry multiplied by 2.
Right. 2 times 4, which made it 8. And so the 16 thirds was on the inside, and then we multiplied it by 8.
No, the answer is
Look, right here. Pause this. Okay? If I change this bound, it's 1/2 pi times 2
I got 32 thirds.
from 0 to 2 of 4 minus x squared dx. The integral from 4 minus x squared
32
becomes,
thirds.
no, it's 16 thirds.
I got 32.
It's 16 thirds.
No, that is 16 thirds. The one up above is 32 thirds.
They should be the same.
I got 32.
If you, I'll do it on the calculator. Hold on.
No, but I'm just
Give me a calculator.
How is it going to be the same?
There's two
Yeah,
different
be-
rounds.
Because you're doubling the area.
Right. So it should be double.
Tyler
guarantee
Hill
you,
and Grace McAvoy, please report to the office.
0 to 2.
Tyler Hill and Grace McAvoy.
4 minus x squared dx is going to equal,
But hold on, what I'm saying
Look.
is
it's 32 thirds.
And then I would do 32 thirds times pi over 2.
no, it would be times pi. He didn't bring the 2 out.
Yeah, he didn't bring the 2 out.
Let's see.
So you have to divide your answer by 2 to get 16 thirds. Because the area is 1/2 pi. Yes.
Yeah, so I brought out pi over 2.
Yeah, so I'm saying your 32 thirds needs divided by 2 to get the 16 thirds we have.
Yeah, so it'd be 32 pi over 6.
I was just
Sure,
saying,
which becomes 16 thirds.
you
Okay,
had,
but I'm arguing with him, not you. I don't know.
Okay.
He's
I'm
making
just saying,
me
when you
confused.
had this,
That-
this wouldn't be 16
Look.
thirds.
It is.
I'm gonna see where
No, it's the
you're going.
32 thirds. 16 thirds is our final number.
Right, that's all I was trying to say.
Okay.
Is that
I
that,
still got 16 thirds. I'm just now
Said
confused.
no, you
Corey's really messing with my head today. You,
No, 32 is the answer before.
yes.
And then you have to multiply by pi over 2.
We're at 32 thirds is the answer before. You,
that's all I was trying to say. And that's- Therefore,
I was
it's
doing
16
fine.
thirds times 8. It's 16 thirds times
Are we
8.
doing
You're
this?
not, the integral from 0 to 2 is 16 thirds. However, the 2 out in front makes it 32 thirds.
Right, that's what I was trying
The
to
area area of the whole circle is 32 thirds. You have to doubt 16 thirds is 0 to 2. You're ignoring the 2 out in front.
And then I multiply by 8.
You multiply by 4 and
It
by
depends
2.
on the problem.
Which is 8.
It depends on the problem.
But the actual.
I know. The reason I
You
multiply
guys
by 8
stop
is
talking.
because
I was doing fine until you started
I was
talking.
fine too.
I was right.
No, but yes, we're just all arguing different points.
I'm not even arguing it.
I
I'm
know.
just confused.
I know.
Corey was
Corey
right. All I'm
is
saying.
no. Corey is confusing
Corey was
everybody.
right though.
So what's the point of you saying that?
Because I was right.
Well, what's the point of
Our Corey
saying
is
that?
right. Because I was right, and then he started arguing with me. Because you said you're wrong.
You were all arguing with everybody about a different concept. Like, do you know what I mean?
Well, it's not my fault.
I was
You're doing it the wrong way.
I wasn't doing it the wrong way. I was doing it the right
She
way.
said wrong, not wrong.
All the ways are right.
Hey, another piece of paper, paper.
It wasn't even that I was doing it the wrong way. I just said, you said that
He said.
you said an integral from negative 2 to 16 thirds. And I said, no,
Well, the interval from 0 to 2
it is 16 thirds.
And
But
then
there's
you
a
also
difference.
compared. In the end, you got it right. You just got confused.
I'm not confused. You're the one that's confused.
1 second. I gotta try to. They lost my mouse on my screen.
How does it feel?
Yeah.
Exactly. Exactly. How does
Hey.
it feel?
Don't know where my mouse is. There it is.